Okay, so now, so far, if you realize the questions that we have been doing, okay, so let me just start with this question over here. Is it? Okay, here. Okay, so far, if you realize the question that we have been doing directly gives you, okay, directly gives you the equilibrium concentrations. Okay, so you have here equilibrium concentrations. Okay, so it gives you directly the values of equilibrium concentration, and all you have to do is substitute it into the KCKP equation. Right? Now, please make sure that sebelum ni, okay, in order to substitute nilai dalam KC atau KP, it must be equilibrium concentration. You cannot substitute in any other values like initial or final. It must be at equilibrium. So that was what we were doing until yesterday. Okay, but today we are going to go advanced. Okay, so what advanced we are going to go is this. Okay, so we have two types of problems. So the first type is whereby the equilibrium quantities, the concentration, partial pressure is given, and what you are required to find is you have to find KCKP. Okay, now what will be given to you is we will be giving you the initial quantities, okay, like the initial concentration, initial partial pressure, Kp, Kc, and you are required to find the equilibrium quantities pula. Okay, so it's now basically like doing it from backwards. Okay, they will give you the initial and the Kp, Kc. You have to find the equilibrium concentrations. Now, when I searched from 1999 to 2018, I realized that the questions are all number 2 type. Tiada soalan jenis 1. Okay, tiada soalan jenis 1. All of it was soalan jenis 2 and also from 6.3. Okay, which we will be learning after this. Okay, so this is important, so please take note, right? And remember what you need to substitute into Kp or Kc, it must be the equilibrium quantity. Okay, right. Now let's look at this exercise. Okay, let's go through this exercise. So this exercise here says at a certain temperature, the mixture of hydrogen and I2 was prepared by placing 0.2 mole of hydrogen and 0.2 mole of iodine in a 2-liter flask. After a period of time, okay, equilibrium was established. So from reading the question itself, you know these two are talking about initial quantities. Okay, they are all initial quantities, right? So once the equilibrium has been established, they realized that the concentration, okay, of I2 had dropped to 0.02 molar. Okay, and the question is asking you calculate the value of Kc for this temperature. So yes, I know the upcoming slide already has the Jalan Kerja, but I want you to follow the Jalan Kerja that I am going to show you, which is, okay, so the first thing, in order for you to score your marks, please write the expression of Kc. Okay, although you only require it at the end of the calculation, but just to make sure you get your marks, write the expression of Kc, prepare it. So it would be concentration of hydrogen iodide raised to the power of 2 divided by concentration of hydrogen, okay, and multiplied by concentration of iodine. That's step 1. And step 2 is the compulsory step where you are going to create an ice table. So please remember the ice table. Okay, this is like for empirical formula. Awak kena buat table yang ada mass, mole, simplest ratio of moles, right? Which is known. Kalau awak tak buat table tu, awak tak dapat markah. So sama, step 2, you must do your ice table. Okay, kalau tak, memang tak dapat markah walaupun mathematically if you do other ways, which can get you the answer, but no, you have to do the ice table for your marks. So what is this ice table? So ice table has got 2 columns. Okay, So the larger column over here, we are going to write out our equation. So please follow carefully. Hydrogen plus with iodine. Okay, double arrow. Okay, the reversible arrow to give hydrogen iodide as my product. Okay, make sure the stoichiometry is written. Next, I want you to draw a dotted line directly below the reversible arrow. Okay, so we are done for that. Now we are going to fill up our table with the alphabet I's. So what is this I's? I's is going to be initial, change, and equilibrium. Okay, so initial, change, and equilibrium. So now for Kc, okay, for Kc, as I told you, the values that you need to put in are all equilibrium values because Kc is the equilibrium constant. Okay, it's the equilibrium constant, right? So you have to put in the equilibrium value. Now, when I talk about value, what value is this? Is it the mole or is it the concentration? Intan?
Concentration.
Very good. Okay, we have to put in the concentration. Therefore, you're going to write here initial concentration, unit capital M, molar, change in concentration, okay, unit capital molar, and equilibrium concentration. Okay, why do we do this? Because we are calculating Kc. Kalau Kp, what will it be? Farah? Kalau Kp, what would I put? Initial?
Pressure.
Pressure, yes. Kalau saya nak cari Kp, I would put initial pressure instead. Okay, I wouldn't put initial concentration. I would put initial pressure. Okay, so now let's go back to our question. Okay, so question here has given you the mole and the volume. Okay, so when you have mole and volume, that means you can calculate concentration. So let's go to your class page. So concentration of hydrogen gas would be 0.2 divided by 2. Okay, 0.2 mole divided by 2 liters, which would be 0.1. Okay, that's the initial concentration of hydrogen. Same for iodine. Okay, 0.1. Right. Now, when I discussed with you Monday, right, I did say that products at initial, the concentration would be 0. Semua orang ingat lagi? Do you agree? If you agree, you can switch on your mic. Tak perlu cakap. So I know you all remember. Okay, right, thank you. You can switch off. Okay, so initial concentration of product, which is HI, is 0 unless stated otherwise. Unless question nak kebat sikit, dia beritahu situasi whereby ada some product in the system. That is the soalan yang paling susah they can ask you. Otherwise, the initial concentration is 0. Okay, so the next thing we are going to find is the change. If you read the question, okay, if you read the question, is there any change value given here? Adila? Is there any change value given in the question? Adila Razzi?
Yes, madam.
Ada? Mana?
Ada. Drop 0.02 molar.
0.02 molar ni is equilibrium. Dia bukan change. Mereka tak beritahu apakah
tak.
perubahan. Okay, tak ada. Tak diberitahu. Most of the time question tak beritahu. Okay, so for that, what we have to do is that in maths, if you don't know something, what would you do? You would put an unknown. So same thing here, I'm going to put an unknown. Okay, so before that, you have to understand that the change that you're going to expect for reactant, okay, will be a negative change. Why? Because I have shown you the graph of reactant against time, whereby the constant, sorry, not reactant, oh God. Okay, I have shown you the graph of concentration against time, whereby for reactant, it will go down. Okay, so this is reactant. The concentration against time, reactant akan go down, whereby for product, dia akan meningkat. Okay, so the change that we are expecting for reactant is a negative change, whereas for product is a positive change. Okay, and what is this change? We don't know, therefore we are going to use an unknown, and this unknown is going to follow your stoichiometry. So stoichiometry of hydrogen is 1, therefore it's just X. Stoichiometry of iodine is 1, therefore it is X. And stoichiometry for HI is 2, HI, therefore it will be 2X. Setakat ni boleh faham? Kalau boleh faham, buka mic. Okay, good. Everyone can understand what's happening. Chow?
Yes, yeah.
Understand?
Yes.
Boleh tutup. Okay. Right, who's the one who is traveling? Ada orang dalam kereta ke? Okay, no one. Right, fine. It's just that the back noise is very loud just now. Okay, so this is the change. So once you have done that, put a line, okay, because we are going to add two things together. Okay, I'm going to put a line. Right, so the equilibrium is basically going to be initial, okay, initial added with the change. That will be equilibrium lah. Sebab daripada permulaan kita akan experience some change and that will be equilibrium. So this is going to be 0.1 minus x. You just add them together. So this is also 0.1 minus x. Addition, I think you know 0.1 campur dengan negative x. So terus akan menjadi 0.1 minus x. Okay, and finally, this one is going to be 0 plus 2x. So it is going to be 2x. Okay, so we have our formulas for equilibrium. And the next thing in the question, if you realize, like what Farah has said just now, was they have given the equilibrium concentration for iodine. Okay, they have given the equilibrium concentration for iodine, which is 0.02. Okay, therefore, as you can see over here, this value is equivalent to 0.02 molar. So show that calculation. Okay, so equilibrium concentration of iodine. So how are you going to write that? Equilibrium concentration of iodine is this shorthand. Okay, I2 equilibrium equals to 0.02 molar. Therefore, 0.1 minus x equals to 0.02, x equals to 0.08 molar. Okay, and you can calculate the equilibrium concentration of hydrogen, which will be the same, 0.02 molar. Okay, because it's, you can see over here it is 0.1 minus x, and the equilibrium concentration of hydrogen iodide pula, it will be 2x, which is 2 times 0.08 equivalent to 0.16 molar. So now I have all the three equilibrium concentration of the species reacting in this equation. So soalan minta cari Kc. So Kc, the expression was this. Now all you have to do is substitute in the corresponding values. And dapatlah jawapan. Where is the answer? 6.2. Okay. So there you have the answer, 64. This is what you have to do. So three simple steps. One, write out Kc, Kp expression. Okay, Kc atau Kp expression. Even if you are stuck with the question, write this out so that you get a mark. Okay, where do you write it? You know you have to get it from your balanced equation. Number two, ice table. Okay, ice table is very important, but make sure you know what unit you are using. Okay, is it going to be what physical quantity you are using? Is it going to be concentration or is it going to be pressure? Sebab kita hanya ada Kc atau Kp. So concentration means we are actually calculating Kc. Pressure means we are actually calculating Kp. Now, I want you to do this. Let's go through the working because I see some struggle at the end part, but never mind, it's normal. Okay, right. 1 minute. Okay, I'm just adjusting my view. Okay, right. So the first thing is that, right, you read the question, you understand that the question is requiring you to find the equilibrium concentration. So for that, you need your Kc expression. Okay, I think you're a pro now in writing your Kc expression, but quickly I will highlight it to you. Carbon dioxide concentration, hydrogen divided by concentration of water. Now, please note, water here is gas. So, jadi kita boleh masukkan dalam equation kita carbon dioxide, carbon monoxide. Okay, so this is our Kc expression. Now, we have to do our ice table, initial. Make sure you write the concentration over here lah. CONC pun cukup, no problem. Okay, unit penting. Kalau pressure, dia adalah ATM, unit dia. Okay, so now, if you see your ice table, I think no problem in for you doing this. Okay, dapatkan initial concentration of your reactants and your products initial will be 0. Okay, change minus x for your reactant. Okay, for your product, it is plus x. Right. So equilibrium, there we have it. This is all our equilibrium values. Now we have the Kc expression, substitute in the corresponding values. And since the Kc value is given, it's going to be 4.06. And basically what you have to do is your math. Okay. So now when you do your math, okay, I think shouldn't be a problem for you also. Okay. So when you tekan your calculator, when you put in all these values in your calculator and you get x1 and x2 value, you realize there is 2 positive values. And these 2 positive values, you have to only choose one. Okay. And you see the first one is not accepted. Why is it not accepted? The answer is already in front of you also. Because it is bigger than 0.1 molar. If you remember, the initial concentration pun adalah 0.1 molar sahaja. How can the equilibrium concentration be more than that? Because equilibrium concentration for reactant, okay, or any other thing, it should be decreasing. And it should be lesser. Okay, so we choose the one which is the lower value. So once you substitute inside x value, you will get all the values. Boleh nampak? And can you see the answer preferred in standard form? Okay, kalau tak boleh standard, sebab apa standard form? Sebab it will give you a nice 2 decimal answer. Kalau tak tulis dalam standard form, you have to do 4 decimal place, even for your final answer. Kalau awak letak 0.03 sahaja, if let's say you were to think that final answer 0.03, salah lah, you tak akan dapat markah. Okay, so please take note, right? So try to give your answers in standard form, 2 decimal place. Okay, so if you give in the numbers, make sure it is 4 decimal place. Okay, 0.03 is not accepted. So the next thing is that all this is keep in mind. So the ice table, I've already talked to you, and I have already told you that you can also equate Kc and Kp using this equation. So this is the next equation over here, next question. So in this question, they have given you Kc, okay. Now, what you are required to do is calculate the value of concentration of COCl2 and COCl2 when the following amount of phosgene decomposes and reaches equilibrium. So that means they have given you two set of part lah. If the initial mole is 5.0 and the initial mole is 0.1. So awak kena buat 2 kali. Okay, A and B. So let's just run through, and what they want you to find is actually the equilibrium. So awak kena tulis ini adalah what they want is actually the equilibrium. Okay, so there you have your high stable, whereby beginning we are starting with 5 mole. So you get your concentration as 0.5, so about 5 mole divided by 10 liter. Then the next thing, okay, you substitute everything into your Kc expression. Nilai Kc pun telah diberi di soalan. If you realize that is the Kc value given in the question. Okay, so then you find your x value. So here, it is very obvious which value you should take. You should take the positive value. Negative value cannot because you will get negative concentration. Okay, gives negative concentration. So negative concentration tak wujud lah. It is not mathematically possible. Therefore, you take x value to be 0.02. So make sure in exam you write also accepted, okay, or chosen, right? Make sure you write that, okay, or you write that chosen x value. Okay, so once you do that, now since we are calculating for equilibrium, make sure you put an EQ over here. This is very important, okay, because we want to differentiate initial and equilibrium. So make sure you put that EQ over there. Same goes to here, okay, concentration of COCl2 equilibrium. So that's part A. Now part B, same thing. Only thing that changes is the value here, because now our initial mole is 0.1. So once you substitute in everything, again, you have a situation whereby you have a negative value and a positive value. Without thinking, you can straight away take the positive value, okay, and get your answer. So make sure to write equilibrium, equilibrium, equilibrium. So here, the tutorial questions that you can practice is tutorial questions 9, 10, and 11. Right. So the next part, okay, will be the degree of dissociation. Okay, I'm going to continue. All right. Once I finish degree of dissociation, I will stop. Okay, because I wanted to practice and there's few other questions that I wanted to do. Okay, so the degree of dissociation. Okay, so the degree of dissociation is the fraction of molecules that decompose into smaller molecules or atoms. So this is very, very simple as you get all the information that you need from your ICE table. What is the information? Change in the concentration of reactant and the initial concentration of the reactant. And this here has got no unit. Percentage dissociation, same thing as degree of dissociation, just that multiplied by 100%. Okay, the symbol for degree of dissociation is alpha. Must remember this. Okay, so a simple exercise. Here they have given you the Kc value, the initial number of mole, and the volume. So whenever you see mole and volume, you know it's going to be concentration. You can calculate concentration, capital M. Okay, so degree of dissociation, as I told you, you need your ICE table. Without your ICE table, most of the time tak boleh kira lah. Okay, unless other informations are given. So do your ICE table. Okay, so do your ICE table. Okay, make sure to have concentration. Okay, so calculate the initial concentration and you need your X value. So how do you get your X value? You have to use your Kc. Okay, find your X value. You will get two values. Memang ini dah macam mathematics. Okay, choose the positive value. Okay, then. Okay, here is an explanation now why they choose the positive value, not the negative value. So substitute into the degree of dissociation equation, which is the initial concentration of reactant. If you can remember, just write it as N2O4 instead of writing it as reactant. Okay, so X divided by initial concentration. So can you see that knot over here? The knot means initial. Okay, or if you cannot remember, no problem. You just write concentration initial, still accepted. Okay, substitute in the corresponding value, dapatlah nilai alpha sebagai 0.125. Now, if this question, if I were to continue, what is the percentage dissociation all you have to do is take the alpha multiplied by 100%, which is 0.125 times by 100 equals to 12.5%. Okay, are we clear so far? This is very simple. Degree of dissociation is very simple. So this you can actually do 4 questions. Question 9, 10, 11, and 12 in your tutorial. Okay, you can actually do these 4 questions in your tutorial.